Hello everyone, my name is Samantha John and I'm one of the co-founders of Hopscotch. And Hopscotch is a programming language for the iPad, and it's designed to help kids get started with programming. So why would I do such a thing? Why do kids need to program? So there's this phrase tossed around that programming is the 21st century literacy. The 13th century literacy was a scribe. And so this is long ago, before everyone knew how to read. If you wanted to write a letter to someone, you would go to a scribe and they would write a letter for you. You would tell them what to write, and you would send off that letter, and the person who got it would have to go to their own scribe to read it. Obviously, things have changed since then. Literacy, reading and writing is now kind of part of our society. You can't really function if you don't know how to read or write. You're going to be pretty lost. If you want to go buy a bottle of shampoo, you better know how to read that word, or else you might end up with a bottle of lotion. So fast forward to 2013, and now technology is everywhere. In the same way that for the last couple hundred years, reading and writing, the written word has been all around us. Now it's technology, and if you want to change the radio station in your car, you need to use a computer. Or if you need to find your way around a new city, you need to use a software program like Google Maps or Apple Maps, maybe. And people these days, you people probably know how to use technology pretty well, but a lot of people do not. And that's a problem, because it's so much a part of our world, and it's actually, the amount of people learning how to do computer science is declining. But the amount of people needed to do computer science is increasing a lot. So this is a graph that shows they expect 1.4 million new jobs in computing by 2020, and only 400,000 computer science students. So that's a big gap. And if we don't fill it, there's going to be no one to run our technology. And that's not good. And here's something else that's not good. Does anyone know who this guy is? Anyone? Someone in the back does. His name is Sergey Alexanikov, and he's a programmer. He was a programmer for Goldman Sachs, and he was the only person to go to jail for the financial crisis. And he was sentenced to 8 years in prison because he put some of his source code from Goldman Sachs on a Subversion repository. And he was arrested by the FBI, he went to trial, and he was tried by a bunch of people who basically were high school graduates and who didn't really know anything about technology. And they didn't understand anything that was going on. So they were like, yeah, this crazy technologist, he's guilty, send him away. And luckily, a year later, his conviction was overturned by a judge who knew a little bit better, and he basically said that the laws that they convicted of him of didn't even apply to the case that he was convicted of. So it's kind of scary to think of how much technology is important to our world and how little people understand. So hopefully I've gotten you a little bit riled up about this. So what can you do? Well, what I think you should do is teach people how to program. And I skipped ahead a little bit, but where do you start? How do you start teaching people how to program? How do you start teaching kids how to program? That's what we're talking about at Hopscotch. Although I do think these apply to everyone. So if anyone has any friends who want to learn how to program, hopefully this will also help them. I don't know if anyone's ever had an 8-year-old come up to them and say, please, sir, I want some more computer science. I haven't yet. But that's not to say that learning code can be exciting. And what people actually want to do is they don't want to learn computer science. They want to make iPad apps. They want to make iPhone apps. They want to change the world through software and make things that people use. And that's very powerful. I know that, when I was in college, I originally thought that I would hate computer science, and I did my best to get out of all my computer science classes, even though I was in engineering school, till finally, my senior year, I had this website I wanted to make, and no one would do it for me. So I decided I had to do it myself, and I learned PHP, and I did it myself, and it was like the best feeling in the world. I was this insignificant college student, and I was making something on the internet that anyone could see and anyone could use, and that was a wonderful feeling. And kids can get that feeling too, and any beginner can get that feeling. And I think that's really the feeling that sets off the spark where you're like, yeah, I do want to learn to code. I want to learn how to do this. So what do we mean by learning to code? So at Hopscotch, we're concerned with not necessarily turning people into professional programmers. Maybe like 8 or 9 is a little young for that. Maybe. But we want to have kids who use Hopscotch be proficient in code, be able to kind of understand what's going on in software and be able to build their own things. So we like to think of it as knowing these 4 steps. So first, being able to come up with an idea, knowing what tools you can use to implement your idea, coming up with an algorithm, and finally putting it into code. So I'm going to talk about each of these 4 things. I'm going to talk about what I mean by it, what are the pitfalls when you're trying to learn it, how does Hopscotch solve it, and then I'm going to try and bring it back to the real world a little bit. And some kids are too young to actually be on a computer, so I want to talk a little bit about what can you do to prepare them for when they are ready for the computer. So the first thing is an idea. So you can't really write a program if you don't have an idea. You need to know what you're going to make. And I forgot the order of my slide. So when you ask most beginners to come up with an idea of what they want to program, it's usually something like this. I'm going to have someone like take pictures of food, and then I'm going to figure out how many calories are in that food and what ingredients, and then I'm going to profit. It's going to work great. And that's actually not a very good idea as a beginner, or really, I don't know anyone who is writing that software to find the calories from a picture. But they don't really know, what tools they have, or they don't know what is really available to them, what's possible, and that really only comes with experience. So my advice is, if you're ever working with a beginner, it's probably best to give them some ideas, because the ones they come up with probably aren't going to be that good, or they're not going to be able to come up with any. I teach a lot of programming workshops, both through Hopscotch, so teaching Hopscotch to kids, or I've taught some Rails workshops. And a lot of times what happens is even the most advanced students, they'll be able to do the thing that we tell them to do, and then as soon as they finish, they're like, what do I make next? What's next? And I'm like, come up with something yourself. But it's hard for them. So I really suggest kind of helping them out with ideas. And at Hopscotch, we try and give people sample projects so that to help them come up with ideas. So this is a truth or dare game. This goes a little fast. Kind of like spin the bottle, but truth or dare. And some kids took this and they changed it around a little bit. They changed some of the words. And it became the Who Farted game, which is actually kind of more awesome than truth or dare. So as long as if you can give them something to start with, often they can come up with ideas, but they do need that first little push. So I really recommend with beginners that you help them out a little bit. And then if you want to think about maybe your kid's a little too young for hopscotch, or maybe you just want to get them off the computer, but still thinking creatively and working on being able to come up with ideas. So one thing I like is, how do I get to, oh, here it is. So have them make up their own game. And this is Kelvin Ball, which I don't know if anyone knows the rules to Kelvin Ball besides Kelvin. But basically, he's had to come up with all the rules for his own game. And then he plays it, and he sees how well they work. So I think that process of coming up with a game, and then, a game is fun, so you actually do want to test it. Because other ideas you might be like, oh, I have this idea, but I can't really do it, so I think it's a good idea. But if you make a game, then you can just play your own game and see how fun it is and see how well it works. I also think it would be really cool to make your kid make their own board game and force them to come up with all the rules and stuff. But that might be harder to get them to sit down and do. So the next topic I want to talk about is tools. So in programming, your tools are your computer. That's probably your most important tool because that's going to run all your code. And also your programming language. So kind of the first thing you have to understand is your computer and how it works. So, computers are kind of dumb compared to a human. So if your mom tells you, do this, this, and this, and this, tells you 6 things to do, you can probably figure out what is the most reasonable order to do them in, and what's the best way to do them, and go from her kind of vague instructions and come up with the specifics yourself. But a computer won't really do that. A computer will basically do exactly what you tell it to do, in the order you tell it to do it, and nothing more, nothing less. And really internalizing that, I think, is kind of the first step for beginners. Because, as I was talking about ideas, I said that that's kind of, even though that's the first thing you need to write a program, I think that's kind of the last thing you learn. So learning about how to use your tools is really kind of where you start when you're teaching someone. So once you understand this kind of idea of sequencing and the idea that computers are going to be very literal and do only what you tell them, the kind of next thing that you should be learning are the kind of computer science primitives. And so those are things like loops and variables and if-else statements and all the sort of basic building blocks of a programming language. And just understanding how those work and how they can work together. So our curriculum designer came up with this little graphic. So loops and lists are best friends. And you probably actually already knew that. You probably know that whenever you have a list, you're probably going to have to use a loop at some point to iterate over it. But you don't think of it so literally. But for a beginner, this isn't necessarily obvious. And they need to learn all of these connections. So it's first of all very important to get them comfortable with the tools. So, have the person learning play with lists, play with loops, and have them kind of just practice. But I think it's also really important, and this is something that a lot of computer science teaching neglects, to try and figure out what tools are right for what problem. Often, if you look at an AP computer science question or something like that, they'll kind of tell you exactly what tools to use. They'll be like, make this text parser that uses this kind of text box as the input and then puts it out as a message view and uses a string and uses whatever. But I think it's much more interesting and much more useful to kind of leave that up to the student and work with them to try and figure out what is the best tool. So a better assignment would be make a slot machine. And what do you need to make a slot machine? And kind of talk through all of those things. Because in the real world, it's not like you're like, I want to make this app, and then there's no second step where someone tells you to use a linked list and tells you what to use. You have to figure that out yourself. So that's kind of a really important thing to learn. So with tools, this is actually something that Hopscotch and other visual programming languages do really well. The nice thing about a visual programming language is that all the tools are there in the interface for you to look at. So in the sidebar, we have this library of the available methods that you can use. And you can kind of collapse or expand them depending on what you're using. There's also like this little event dropdown that has all these cool iPad native events. I couldn't figure out how to hook up my iPad, but there's like some fun demos I can do with that. So if anyone wants to see me after, I can show you like the cool things you can do with like tilting or using the microphone input on your iPad. And one interesting thing we found is that as their users get more advanced, they take the tools that we gave them and they use them in unexpected ways. So we purposely only let people use these characters that we came up with and that our illustrator drew, because we wanted to keep a consistent look. We wanted their programs to actually look nice. I don't know if anyone has ever used Scratch from MIT. Anyone? Almost everyone. So Scratch is awesome. We were definitely very inspired by Scratch. But one thing they do is they have this huge library of art that you can use. And by art, I mean there's like clip art, and then there's also like photo cutouts of people. And there's all this just really weird stuff that doesn't go together at all. And we were kind of like, we want Hopscotch users to only make things that go together and look nice. But they actually kind of foiled us because we let them make a text object. And they came up with all these like funky things you could do with text. So someone made the solar system. We didn't give them any planets, but they just used letters. And, oh, whoops, I'll keep the solar system up for a second. And another thing people did was they used emojis. Turns out you can just blow up emojis and they look like art, kind of. So people use that to add different characters that they didn't have. So it was both a little distressing and pretty awesome that people were able to take this limited tool set that we gave them and use it in unexpected ways. So lastly, about using tools in the real world, I think these kind of like crazy art sets that have like everything you could imagine, they're like a really good learning tool in that you have all these choices of things you could use, and you have to pick the best one. And the best one is not the same for every situation. So, if you want to make a poster to bring to the hockey game, maybe like colored pencils aren't the right tool. Maybe you want some thick markers. But then maybe you want to make like an impressionist landscape of your front yard. And then maybe you want to use like some watercolors and not maybe skip out on the crayons. So I think that this is something that really maps well to the real world. And so learning about how to pick the right tools in computer science actually, helps you out in the real world when you have to pick the right tools for your art project, and vice versa. So this is actually, I think, a very useful skill. So after you've figured out kind of what tools you need, the next important thing to do is figure out your algorithm. And algorithms, I think, are the thing that's like most famous about computer science. Like everyone knows about algorithms. Like this is an algorithm, maybe. And they also, I think, a part of that is that they map really well to the real world. You can have an algorithm to make money on Wall Street. And if you have one, tell me. Or you can have an algorithm to do your taxes. So I think this kind of makes a lot of sense to people. And the important thing about algorithms is that in order to write one, you have to kind of put yourself in the computer's place and learn how to think like a computer, which actually takes some practice. So that's kind of the important thing about algorithms. So with Hopscotch, we used a lot of the kind of ideas from Seymour Papert, who wrote this language called Logo. Some people have talked about it in other talks. So these characters are kind of like the Logo turtle, and you can write an algorithm and see visually whether it worked and how it messed up or how it did well. And this is actually from a workshop we did with kids at this thing called the Lab Miami, and that's their logo. So we asked all the kids to kind of create their own algorithm to do the logo of the Lab Miami. And if you saw earlier in the video, there was a completely different looking logo than this one. And some people did it with lots of different characters making the logo simultaneously, so it was a little faster. So people came up, even though they all had the same idea to start with, they came up with a lot of different really creative algorithms, which was really cool to see. So the real world way to learn algorithms, there's a lot of real world ways, but I think this game is really fun for kids. It's called Program Your Parent. And it's not really a game, but it's basically you let the kid tell you what to do. And I think kids like that a lot. I think they like telling adults what to do. But the catch is they can't just tell you to make a sandwich, because you don't know how to make a sandwich. So they have to tell you every little step along the way and teach you how to make a sandwich. So basically, they have to if they want to make you do something, they have to come up with an algorithm to make you do it. So this is a good thing to try out if your kid's a little too young to program or just in daily life. So the very last step of creating a computer program is the actual code. And this is where you put your algorithm not to paper, to computer, and make it work. But there is a problem, which is that code is really scary. I don't know if anyone here is an iOS developer, but this is Xcode. This is actually Hopscotch code, except it's totally terrifying. There's all these little red exclamation marks on the side, and there's all this text on the bottom, and it feels very opaque and very intimidating. And code is kind of where things start to go wrong, I think. And it's unfortunately a lot of the time where people start. If you use Codecademy or Khan Academy or those things, you have to start out by typing in your code before you've really thought about all the other things that you need to think about. So I think this is one of the things that can turn people off to computer science really fast, is when they start writing some code and the first thing they do is fail. And usually the first thing they do is fail. Because people who aren't programmers are really bad at typing programs. Which, it's kind of fair, because I don't know when the last time I used a curly brace in my regular writing was, but it's probably when I was writing a blog post about programming. And even worse, if there's any kids in the room, cover your ears. Kids can't type. That's why they take typing class. They're really bad. They're really slow. And so if you're trying to teach kids to code and you're like, okay, type this in, and you expect them to type it in, and they're like, I can't find the Z on the keyboard. And you're like, oh, we're working at a different level than I thought here. So that's something that Hopscotch really tries to address. So Hopscotch is not scary. So you make a little new project. This is coding in Hopscotch, where you're going to make a circle. And all you have to do is drag and drop these nice, friendly little blocks around. They're colorful, and you can't really get error messages. You're not going to get a seg fault or an unnamed parameter or anything like that, because it just kind of works. I mean, you might not program the thing you thought you were programming, but you will program something. So So this is a little circle. It took me a really long time to calculate how many repeats I needed. So you have a little cupcake drawing a circle. And hopefully that felt really friendly and you felt like, oh, I could do that. I mean, I guess you guys are programmers, so maybe you felt like that when you saw Objective-C too. So, but hopefully anyone would feel like they could do that and that it would be fun. So coding is like kind of hard to think of a real world example because coding is like by its nature, it's so much on the computer. But actually, if anyone's ever done any knitting, knitting patterns are actually a lot like coding. Basically, it's like an algorithm, and you are the computer, you the knitter are the computer, and you have to follow the instructions exactly, and then you will come out with a beautiful Fair Isle sweater. And actually, like people who knit turn out to often be really good coders. Our curriculum designer was working with girls who code this summer, and she told me that her best student was this girl who is also an avid crocheter. And crochet patterns are similar, except that they're all text. So they actually are words that say what you should be doing. And for her final project, she made this little, like a REPL for crochet patterns, where you could type in a crochet pattern and press play, and it would show you what it would look like had you crocheted it. Which is sweet, because apparently for crochet books, they have to hire like 5 people to make every pattern to make sure it works. And then she just did it in code. So this is a high school girl who had never coded in her life before this summer, and then all she had been doing is crocheting. So teach your kids to knit. So in conclusion, I hope you guys have all picked up some tips about how best to teach people to code and how best to teach kids to code. And I hope that you go out in the world now and tell people to use Hopscotch, or tell people to use Scratch, tell people to learn how to code, and that you've realized how important it is, and how much better people's lives would be if they knew how to code, because it's really fun. And then I just want to say thanks to the people who helped me a lot, Ashley Gavin, Jocelyn Levitt, Peter Bell, and Steve Ellis. Now, if there are any questions, I can answer them. Yeah?
So it looks like Hopscotch develops applications to run on an iPad. What things have you, what do you project doing with it next? Anything off the iPad? Anything?
Okay, so the question was, Hopscotch right now is on the iPad. What are you guys going to do next? Our current plans are to continue working on the iPad application. We have a lot of ideas for how to make it better, for how to help people come up with more ideas and help people learn better on the app. We also would love to make an Android version once we have the bandwidth. We actually don't want to do it on the computer. I don't know if, for people who have used Scratch, I think it becomes a little bit tedious sometimes to be dragging and dropping so much. You're kind of like, I wish I could just type this, because that would be faster. But actually on a tablet device, it turns out that you don't really get sick of dragging and dropping things. It feels much nicer. It feels like the natural interaction, and you actually would rather do that than type. Unless maybe you have a keyboard attached, but that's kind of a different story.
I was wondering anything that would allow 2 systems or more systems to interact. So multiple iPads or an iPad in the server.
Yeah, so he asked if we would be having multiple systems interact. We really want to do like hardware integrations. So there's a lot of Bluetooth technology coming out, and the new iPhones, I think, have this, not near field, but something similar, beacon. So I think there's a lot of opportunities to work with other like toys and be able to program them using Hopscotch. I think it would also be very cool if people could program Hopscotches that could, hit APIs on a server, or that could maybe interact with one another, maybe like Pokemon or something. You can play Pokemon against one another, right? I don't know, that was a long time ago. Are you in the red?
So I thought your comment about kids being bad at typing was really interesting and insightful as being a barrier to learning to program. But sort of that aside, if you have a certain level of, sort of typing ability, typing studies on kids that compare between, say, teaching a kid Lisp, which has very regular syntax, no matter how a lot of different control structures and whatnot, versus a visual programming language? And what sort of research do you do to evaluate how well your approach works relative to other possibilities?
So the question is there any research about teaching kids a typed programming language such as Lisp versus a visual programming language? That's a good question, and I don't know of any, but I'll look for it and I'll post it on Twitter, my findings. But I have seen that at the Harvard Introduction to Computer Science class, they're using Scratch actually for the first 3 weeks of class. And anecdotally and from talking to people who have done a lot of teaching, I think even if you can type, even if you are like a relatively good typer, just like the mental overhead of learning so much syntax while at the same time learning so many new concepts can be really challenging. So being able to just focus on learning the concepts separate from learning the syntax can be really helpful when you're starting out. Yeah?
I thought it was interesting when you said, when you're talking about like the art set and having like a large number of tools to choose from, where a lot of maybe like more advanced people would like put arbitrary restrictions on themselves, like they have to make this work on an Apple II or something. I was wondering, just like, do you think those are helpful for kids, like having those constraints, or is there like a tipping point? Or?
Okay, so the question was, would there be an advantage of limiting your tool set? So there's a really large art set, but maybe sometimes experts will say, okay, I have this really large art set, but I'm only going to use crayons or something of that nature. And I think that can be really helpful for creativity to kind of put some arbitrary limits on yourself, because then you're working within a smaller system rather than trying to imagine the possibilities among the whole world. So yeah, I think that can be really helpful, and that's something we've actually talked about doing with Hopscotch, is giving people challenges with a limited number of methods and not letting them use everything at once in order to kind of spark their creativity. Yeah.
So what age range have you targeted this?
So the question is, what age range are we targeting? Probably 8 or 9 and above. We've definitely seen kids younger than that, but the younger kids tend to, I think they don't have the capacity as much to think in the future, so they tend to just kind of randomly put methods into the script and then see what happens. And they're usually pretty entertained by what happens, but they're not necessarily coming up with an idea and executing on it. Yeah?
I like your example with the scribe, but the difference between reading and writing and coding is reading and writing evolved with us for 1,000 years and more, while coding is fairly immature, 50 years. So don't you think rather than pushing us towards the machine, maybe it's better to bring machine towards us, so evolve the medium rather than...
Okay. So the question was, or he said that reading and writing had evolved with people over a long time, so maybe what we should be doing is evolving coding rather than evolving people. And I think that's a good point. I think that there's a lot of things coming out to make kind of understanding technology easier. We hope that Hopscotch is one of them. There's also like if this then that, to kind of introduce people to these topics without the kind of really challenging, like syntax heavy type, like configuration heavy type of environments. You with your hand raised really high.
Have you, for more advanced kids, have you seen apps like Pedagogy where they actually type Lua on the iPad, but they're still graphical helpers?
Yeah, he asked if I'd seen Codia. Codia is an iPad app that you can program Lua on your iPad, and it has a lot of nice little editor features. Like there's a color picker and various like inline help type things. Codia is really cool. I think that even from what I've seen of it now, you kind of have to know Lua beforehand before it's really going to be useful. But if you do know Lua, and I think you also probably have to have an external keyboard, because it's still pretty hard to type on your iPad that much. But I think within those constraints, it can be really awesome. So I would definitely recommend it as kind of a next step after Hopscotch if your kid is getting really good at programming. You with the red hair.
You suggested that you've taught Hopscotch in group settings with children. I was curious, like, what kind of methodologies you found effective or ineffective in working on teaching this, like, in a group setting. Like, did the kids pair on working with it, or is it? Do you leave the iPad in the room in kind of a directed Montessori style kind of environment? Like, what has been most effective?
So the question is, what's been effective at teaching Hopscotch in group settings? Well, a lot of the time, we don't have enough iPads for everyone, so they actually have to pair. But I think pairing has worked really well, and I found that just to be a really effective learning tool in general. Although sometimes there's like the kid who hogs the iPad. But I think people have a lot of fun working in groups, and kids like to be social and hang out with each other. One thing that worked really well is we would put an iPad on AirPlay, so we'd have it on a big screen, and then sometimes we would just show them a project. We would show them the end result of a project and say, "Can you do this?" And kids tended to have a lot of fun with that. And then if you just go around the room and kind of unblock people, it works pretty well. But I think the most important thing is having a good supply of ideas of things for people to make. If you just kind of let them loose with the iPad immediately, I think they have a hard time deciding what to do with it. All the way in the back.
Can you give any suggestions more generally of good resources for teaching and pedagogical methodologies?
So good resources for teaching and pedagogy. I really like Seymour Papert's book, Mindstorms. I highly recommend that to anyone who wants to teach kids. I like Brett Victor's work a lot. It's not directly related, but he writes a lot about creating interfaces that will help people program better, especially beginners. Hopscotch is in the process of publishing some curriculum. So please feel free to get in touch with me on Twitter, by email, or just talk to me after, and I can give you some previews of those curriculums.
What's the name of that paper you mentioned?
The paper?
Yeah.
Oh, Seymour Papert. It's Papert. It's his name. And the book is called Mindstorms, like Lego Mindstorms. Yeah?
I'm guessing most people here wouldn't have any trouble teaching their kids using something like Hopscotch or something. What can we do for children who don't have parents who are programmers? Like, what can people in this room do to help kids who wouldn't have that support in the home?
So what can you do to help kids who don't have awesome parents who are programmers? Well, I have a friend who has actually started an after-school programming class at his kid's school. So if you have the time to do something like that, I think stuff like that is always really wonderful. There's also Coder Dojo, which is this fantastic organization. It's all over the world. It started in Ireland, and basically they host like kind of free coding sessions for kids of all ages to come in and learn some programming. And I've been involved with the New York Coder Dojo, and it's been really successful. So starting a Coder Dojo in your neighborhood is a really great way to get kids interested and give them some exposure.
I'd like to take a stab at that one. I just think that kids tend to gravitate to their moms. So if you teach your wife how to code, she'll teach some other women. For every woman who learns a thing, you actually end up teaching 6 people, because the woman will teach 5 other people. Teach women how to code and the whole world learns.
Teach women how to code and the whole world learns, exactly. I love it. Yeah.
Thank you for doing this. I think you have a lot of excited parents. Have you thought about games for even younger kids that are just really simple that may teach even an inkling of an idea? For example, I have a 3-year-old who I just noticed started sorting things by color a lot. I would love if there was a touchscreen game where he could just even sort by colors, and maybe a next step after that.
Okay, so games and apps for kids who are too young for Hopscotch, like 3 or 4-year-olds. I've seen, there's a thing called Codable with a K. It still might be a little bit old, but I think it's a little bit simpler than Hopscotch. And at Hopscotch, we actually the very first thing we did before we even, it was like a side project before we had even left our jobs to do it full time. We have this app called Daisy the Dinosaur, which is aimed at slightly younger kids. And it's a programming app where you program this dinosaur to do various dances and the like. There's also this Kickstarter that's gotten a lot of attention called Robot Turtles, I think. And it's a board game to teach kids programming. I haven't actually used it, but it seems really awesome. Yeah.
Yeah, I taught at a school where we have good luck sort of with pre-programming stuff using crazy machines from Vina Media. It's a kind of a wall that you have various gizmos.
Oh, okay.
And you plug them together and they do various things. And maybe you don't have enough cord in this one to get the fan all to, you have to get like the light bulb lit up, but it's like you don't have enough cord, but you have a fan and a generator which has a like windmill on it, and you can like arrange those.
That's awesome. So crazy machines. And I actually think there's an iPad app called Tinkerbox, which is a little bit similar, I think is along those same concepts. So maybe that also could work. Yeah?
What inspired you to want to help kids?
What inspired me to want to help kids? Well, to be perfectly honest, I was kind of inspired to help girls. But then we decided that all kids could use it too. And I mean, it was pretty natural for me because I was a girl in the sciences, and I kind of saw that, you know, in middle school there were tons of girls in math class, and even in high school, I didn't really notice that girls were worse at math than boys. And then all of a sudden in college, it was like I was the only girl, and so I started thinking about why is this and how can we solve it, and kind of came to Hopscotch eventually. Yeah.
Yeah, so on the question of, you know, games for kids, I would just really encourage everybody to like play board games with kids. I mean, I have 2 kids who are 4 and 6. They're obsessed with this game called Mice and Mystics, which is like, it's a ridiculously complex game relatively, but it's, you know, this dungeon crawl adventure that's cooperative, where your kids are mice and they're, you know, fighting spiders and stuff in a castle. And things like that where, you know, if I come home at night and they're like, can we play Mice and Mystics? Sure. You know, but as far as other games that are really closely related to programming, Robo Rally is one where it's very much about, you have to think about, okay, this card's going to make the robot go forward, this card's going to make the robot turn right, and I think that's a really good game.
Okay, cool. So he said good things for kids are board games and such as Mice and Mystics and Robo Rally.
Anything that you can play with them, right? You know, it's and especially things like cooperative games where you're not playing against them, where everyone is fighting against a common enemy are excellent.
Okay, so cooperative games also good. Yeah.
Yeah. So have you heard of the CS Unplugged curriculum?
The CS Unplugged curriculum?
CSUnplugged.org.
I haven't.
So it's basically an entire curriculum that's aimed at kids, you know, pre-high school age kids, that teaches computer science about computers without programming. So for instance, they structure, you know, error correcting codes as an academic strength, so that you can play this game where I'm able to tell if they can I've seen it work real well with people that show computer code that makes sense.
Oh.
It might influence the section of your talk where you say,
Yeah.
There's a lot of programming. So programming
So CS Unplugged, also a great resource that I will have to check out myself. Okay, I think it looks like time is up. So thank you everyone for coming.